Yeah. So the first project I want to talk about is a net zero home we're building with zero energy design in Belmont. Um, just a little background about Auburndale Builders. We specialize in high performance building or remodeling. We built the first certified passive house in Wayland. Built the first all electric net positive home in Newton. That project was designed by ZED, and our office is this first certified passive commercial building in Newton. So the project in Belmont started as it was like a garage addition to an existing building. So if you look at the center floor plan, we built the structure on the left side, the section that says garage. That addition consisted of a new garage, an owner suite. There's a guest suite below on the first floor, and then there was a bunch of storage. And originally, the building that is on the right side had a similar, like multi-level floor plan and a similar mass. Um, so the initial plan was to do this addition. Then the clients were going to move into the addition, and we were going to do a deep energy retrofit in the existing building. By the time we finished the first phase, we did some exploratory work in the original building on the right side and realized that the existing foundation that was built in the 60s didn't have any footings, and we reached a point where it wasn't cost efficient to do the deep energy retrofit, so we ended up tearing down the first phase. So we ended up doing an addition to an addition that we did, technically. And so this house, it's like a really modern look. Uh, all the gray areas are cedar shiplap siding. All the windows are triple glazed European windows with like really huge pieces of glass. So some of those, the doors are like 13 feet by 8 feet tall. And then in the back, we haven't built this yet, but they're adding these two roof decks on both structures with a bridge in between both of them. Um, and the building has like a really interesting layout. There's like a connector between the two buildings. Uh, the side on the left, like I mentioned, has like the master suite. There's an office and a little kitchenette area, and then the other side has the kitchen, play area, and then the children's rooms on that side of the building. The wall assembly for this project, uh, we have a 2x6 standard wall filled with dense packed cellulose, and then on the outside we have two layers of polyiso 2-inch, and the roof is a 2x12 with an additional two layers of exterior insulation, 4 inches of EPS underneath our slab, and then the whole building has an air barrier, and the building is almost completely airtight. There's just a couple of shots of the building completely wrapped in exterior insulation. So the photo on the left, because that's a picture of our rain screen on top of our exterior insulation, because we used like a vertical installation of the shiplap. We had to put the rain screen at an angle so we could have airflow and vapor flow. And then below grade we have Roxel, and that can be underground, and we can push the dirt right up against it. And then the photo on the right is just a drone photo of the whole building wrapped with the two layers of polyiso. Like I said, the whole building, the architect specifies the Mento 1000, so we wrap the entire building, and we test the building a couple of times with a blower door. Underneath the concrete slab, we use a Stego wrap. All the penetrations are taped and sealed, and then we pull the wrap up the foundation wall a little bit, and then tape that entire seam. So again, just a couple of phases during the project is when we'll run the blower door. So in a perfect situation, before we cut in any of the windows, we'd run a blower door, but because of some scheduling conflicts, we kind of didn't go that route. But before we insulate, we'll run the blower door for a day, and then in this project we ended up spending like a half a day just chasing all those little air leaks, and made the photo on the left, or I'm sorry, on the right. My screen's covering it, but was in the morning of the blower door that we did before we insulated. We were able to cut down over 100 CFM. This house, we put triple glazed European Schuco windows, really large openings. It took a lot of guys to install these windows. For the larger windows, you actually have to take the glass out of the frames, install the frames, and then reinstall the glass. It takes like 5 or 6 guys just to load these into the openings. The photo on the left is just the prep work that it takes around the opening. So we use a Vicor at the sill, and then a dam behind the window, so no water can get in behind the sill of the window, and then stretch tapes in the corner. And this house has like some really large door openings. There's like a triple slider at that front entry there. And then I think the pictures, there was a good contrast between just like how delicate you have to be with the prep work and making sure that you're taping and waterproofing all the sills before you install in these doors. And then there's like, it takes a certain amount of brute to install these large doors and windows. So it's just a contrast of taking that time and delicately installing everything, and then using all your might to lift these things into the openings. The other project we have going on is a net zero home in Weston. This is just some of the details for that project. We are using a 2x8 wall assembly, filling that with dense packed cellulose. And then on this project, we're using salvage foam. So there's a company out of Worcester that they'll deconstruct commercial buildings and take all the insulation off of the building, salvage it all, and then they resell it all. So you kind of have to take what they have. But this is, for example, like you can't see it on the corner there, but I'm sorry, we can't really scroll in. But the goal was to achieve 4 inches of exterior insulation. They had 1 inch available, so we had to buy hundreds of sheets of 1 inch and just layer that on to get to that 4 inch. In a perfect world, we'd have 2 layers of 2 inch salvage, but we take what we can get. It's like 30 or 40 cents on the dollar, and we're keeping saving a lot of waste, and that's not ending up in a landfill. And the material is already off gassed and pre-shrunk a little bit over time. Sometimes the polyiso will shrink, so you don't have to worry about that long-term shrinkage. The shrink is already done. Cool aspect, something that we haven't done before, is worked with these glulam beams. So these glulam beams we install at the framing stage. That beam that we're looking at is a 24-inch tall beam, 3 inch by 24, sandwiched between a 1/2 inch piece of steel. So, and then bolted all together. And that's like the main structure of the house. And it's also going to be exposed at the finish. So like the next picture shows that that whole first floor is wide open with these 24-inch beams, and then also in between there are 16-inch glue lam beams, kind of like a ski resort or a ski chalet. Really cool finish, I think, and kind of interesting at this point to be, we're still framing the rest of the building, but all the exposed beams are sealed, and that's going to be our finished product. And then in between the beams, we'll have like a beadboard, a fur beadboard. Yeah, so I haven't used those before. It was definitely a challenge. We had to bring in a crane just to set them all. But I guess it's not really much different than installing like steel beams. But yeah, really cool project. And just another slide I wanted to throw in. This is from the Belmont project. Both doors, there's no step at the door, so it's seamless detail. So we had to create like a gutter right at the door. And I just thought that this photo on the right that the architect detailed to all the different steps for the flashing and the water barrier, just so many notes and little details that we had to follow. And then we just made a mock-up and got approval and went forward with that. Yeah, that's all I really had. That's our one project wrapping up, and then our bigger project that we have going on. I don't know if Milo's ready to start sharing, but
just about. Okay.
Well, folks can ask questions about this one.
Yeah, please ask any questions.
I'm curious. I like that you mentioned you use the rock sole there, kind of for the lower end of that Belmont project. Did you use that under the slab as well?
No, we used EPS under the slab.
All right, so that's just on the sides there of the basement. And you said you just put the dirt right up to that.
Well, we put a drainage material on top of it, but it can be submerged. And then actually we're using a salvage EPS on the Weston project underneath the underneath the slab.
I have a question on the Weston project.
Yeah.
Is that on Beach Road?
It is.
Yeah, I've been working next door, and both neighbors across the street and next door. I was wondering, quite a project. John Young is a friend of mine.
Oh yeah, John did all the excavation. Yeah.
Yeah, he's awesome.
He was there today. Yeah, he's great.
I had another question for you. The one on the Whalen project, is that on the Benjamin land? Is that on 126?
Yes.
Pollock, is that the name of the family?
Whatever.
Never mind.
Yeah.
Just been watching that. That's it's a great looking project. And
yeah, that one came. That was like the first project that we were able to learn about high performance building on, and the client was very patient with us, like figuring out a lot of the details as we were building it.
Was the house torn down before that on that same lot, or is that?
I think there was an existing. There was a building that was torn down, but the property, the homeowner, I think, grew up in. Shares the lot with it, so they built the house and they stayed in the old house, and they ended up tearing that down. And then I think their solar field is in where that old house was.
Hey, Ryan, I have a question on the, it's just maybe general, but I think you showed the foundation on the Belmont project. Are you using what are you using for a capillary break between the footing and the stem wall? Is that spec'd or?
Yeah, off the top of my head, I don't remember the product. But yeah, we do always use a capillary break. It was specified by the architect.
Like, do you know, is it a membrane or a?
We used a membrane once on another project, but the form guys weren't crazy about it, so it was easier to because we had rebar coming up through the footing, so it was hard to put the membrane right on.
Yeah, the reason I ask is we just went through that, and I think the membrane that the the architect proposed was a Delta, maybe it's Delta.
Yeah,
short
that
end.
sounds familiar.
But then there was a lot of rebar added, and so we ended up using a liquid. But
Yeah, it wasn't really an option for the same reason.